So this is what the cell bio spreadsheet looks like if you're doing this in Excel. So you can press F9 or just type in the spreadsheet. It doesn't matter what you type. It will just keep changing. So you can think of that as a unique person. Every time the data changes, it's resetting randomly. So you would look at the color change. This brighter color indicates that clumping happened, that a reaction happened, and these here would indicate no change, no reaction. So you would essentially just generate 10 random blood types, type them out. So starting with this individual here, that would be A negative, because that's the only reaction we see. Now this person here is O negative, another A negative person, B negative, A positive, B negative, AB negative, another AB negative, A negative, O positive. So now I have my 10 blood types, and this random pair will be matched together. So 4 and 8, keep in mind the spreadsheet's constantly changing, so you kind of just take a snapshot of what data you want to use. It doesn't necessarily matter a whole lot, but individual 4 and 8, let's say. So 4 is B negative, 8 is AB negative. So we know individual 8 has type AB negative, so we know both alleles are A and B. That's the only option with that blood type. But with individual 4, who is B negative, we don't necessarily know whether the B allele is homozygous dominant or heterozygous. So in that case, we would just look at whether it's got 2 capital H's listed here, or capital H and lowercase h. So in this case, we have the heterozygous genotype. So basically a carrier of the type O blood type. So then we fill out the Punnett square, and that gives us our possibilities. So there's a 25% chance of having a child with type AB blood. We've got a 50% chance of type B blood. Now there's a 25% chance type B blood would be passed down, and this would be homozygous dominant, whereas there's another chance of having a heterozygous B blood type. And the whole probability, there would be a 25% chance of having type B and being a carrier, and a 25% chance of having type A blood. So, determining the probability kind of depends on what exactly you're looking at. So if you're looking at only the probability of having type B blood, then that's a 50% chance. If you're looking at only the probability of having type B blood and it's homozygous dominant, then that's 25% chance. So that is what you're doing with this. I just have general color-coded squares, but in Google Sheets, it changes if you type in the spreadsheet, although you might, type and not see any change because the same thing is randomly generated. That happens. That's fine. In this case, we would do the same thing. This person would have type A positive. This person is type A negative, and so on.